In this example, we're going to look at the chain rule and apply that to take the derivative of e to the 1.03t minus 1. And I'm going to do this using three different kinds of notation. Z notation, fill the box notation, and in your head notation. And I would not recommend that most students do this problem three different ways, but it might be useful for you to pick your favorite notation and also to look at least once or twice at the other ways of writing it, because it might help you understand better what each piece of the formula is doing. Okay, so first solution will be the Z notation, and I'll start by reminding you what the chain rule looks like using that notation. dy dt equals dy over dz times dz over dt. So that means I should take the derivative of one variable with respect to another, and I should multiply a couple of them together. And let me also, on the same screen, remind you what the formula was, the function, y equals e to the 1.03t minus 1. Okay, so the first step when you use z notation is to identify what will be z. And I usually say it's the inside of a formula. Sometimes that's kind of obvious what that means. In the case with the exponential function, people often have a little trouble seeing it, but it's almost always in that case the top of the exponential function. So that's what I'll use. Z equals 1.03t minus 1. And if I do use that z, then I can rewrite y, and I can just say that y is equal to e to the z. So of course you could combine those two formulas and you'd get right back to the original y equals formula, but I'm not going to combine them. I'm going to use them separately in the chain rule. So I should take the derivative of each of these formulas with respect to the variable that you see. Let's start with the second one. So the derivative of e to the z. This will be dy over dz. The derivative of e to the z is simple. You don't do anything with e to the x or e to the z or e to some other variable if you're taking the derivative with respect to that variable. So it's just e to the z. And now I should take the derivative of 1.03t minus 1 with respect to t. And that derivative will just be the coefficient of t, namely 1.03. And what the chain rule says is we should multiply those last two formulas to get our original derivative. So dy over dt equals e to the z times 1.03. And that is the derivative, but it's not really fair to start a problem that involves a function of t and to end it and have no t's left but only a z. So we should go back and we should replace z with the exact original thing we started with, namely 1.03t minus 1. So you plug that in and you get e to the 1.03t minus 1 times 1.03. Okay, so we're done, and now let's try the same problem but using a different notation. So in the fill the box notation, what I do is I take the usual derivative formula that you might write with x, and I replace the x with a box, and the box represents like an empty space into which we can plug something. So that's the chain rule idea, is putting one thing inside the other. Okay, so here's how the derivative looks like in the chain rule box notation. The derivative of e to the box equals e to the box times box prime. And we will put something inside of those boxes. In fact, we'll put 1.03t minus 1 inside each box. So let me write it over again, but with a little more room to put that. And then now I'll show you how it looks when you do fill that in. So the derivative of e to the 1.03t minus 1 equals e to the 1.03t minus 1 times 1.03t minus 1 prime. And what that last prime does is it reminds you we haven't actually taken that derivative yet. So we still need to, and we'll do it in one more step, and I'll also stop writing the boxes in that step. So e to the 1.03t minus 1 times 1.03, which is the derivative of that last box. So of course that's the same thing we got in the previous solution. Okay, so now I'm going to do it one more time using what I call in your head notation. And what I mean by that is instead of writing a z or a box, I will just have certain words that I use either in my head or in this case out loud to remind you which part of the formula we're looking at which time. And in that case, what we should do is we should take the derivative of the outside, we should not change the inside, and then we should multiply by the derivative of the inside. And I will color code these in red, blue, and green so that I can also show you when we're looking at the formula why I'm doing a certain thing to each part. Okay, so the original formula, derivative with respect to t of e to the 1.03t minus 1. Right now it's in black, but let me show you the inside and the outside parts. So e is the outside part, and 1.03t minus 1 is the inside. To be a little more careful, it's e together with the fact that it has something up on top of it. But the e part, maybe you'd say the e on the bottom, is the outside. So what do we do when we take the derivative of e? We don't do anything. So it still should just be e. Of course, I'm not done, but I'm just saying that part doesn't change when we take the derivative. What should we do to the inside? Nothing. So 1.03t minus 1. Okay, and then finally, what should we do? And then multiply by the derivative of the inside. So I'm going to wait for another step to actually finish that, but I'll start by just putting it on the side with the prime, and what that prime says is you still need to take the derivative, but this is where it's going to go. So my last step will be to finish taking that derivative and to write it on the side. So e to the 1.03t minus 1 times 1.03. And of course that's the same as we got before, but now we can kind of see with the colors where the z is or where the box is, and hopefully that helps you.